Good morning, Group B. Good morning, guys. This is your teacher, Roderick, and welcome to CHI Online Training. Our subject today is Electric and Electronics Fundamentals 3, and our lesson is Inductive Reactance in Series Circuit. So let's start. Before anything else, let's define what is inductive reactance. So inductive reactance is the opposition to current flow through an inductor is proportional to both the amount of inductance and to the frequency of the current in the inductor. This opposition to a change in current flow is called inductive reactance. Now, the symbol of inductive reactance is XL. And the unit of XL or inductive reactance is ohms or the symbol omega. Now, what is the difference between inductance and inductive reactance? Now, the difference is that inductance is the ability to create a voltage within a conductor or a nearby conductor by changing the current flow in the first conductor. While the larger the inductance, the greater the voltage induced per change in current. And inductive reactance is the opposition to a change in current. So the inductive reactance will just come out when there is a change in current. Okay. Now, let's proceed to inductive reactance in series circuit. So this is the circuit of an inductive reactance, or this is a series circuit of inductors connected in series. So we have here the L1, the L2, and the L3 connected in series. So we are going to get the XL of L1, inductor 1, and we will going to get the inductive reactance of L2, and we will get the inductive reactance of L3. Now, in this circuit, we can compute also the current and the voltage of L1, the voltage of L2, and the voltage of L3. Now, in this series circuit, we have this source voltage, which is Bs, and the frequency. Okay. Now, our source voltage is AC. This is the symbol of AC, or alternating current. So the formula of inductive reactance is XL. L means inductor, and X is the reactance. So we call this one inductive reactance, and which is equal to 2 times pi times F times L. Okay, remember the value of pi is 3.1415, and the value of F is this one here. This one is given, and then the value of L is this one, the 3 inductor here. Okay, it's either L1, or L2, or L3, or total inductance. Okay. So you can solve for total inductive reactance by using this formula. Okay, so we have here XLT, or total inductive reactance, is equal to XL1 plus XL2 plus XL3 plus so on, and the number of inductor or inductive reactance in the circuit. Okay, next. Inductive reactance in series circuit. So we have here the example circuit or problems. So we have here the source voltage, which is equal to 20 volts, and the frequency is 60 Hertz. And then the value of L1 is 3 millihenry. The value of L2 is 7 millihenry. The value of L3 is 9 millihenry. These three inductors are connected in series. That is why it is called series circuit. Now, the problem is we're going to solve for the total inductance, the total inductive reactance, the XL1, the XL2, XL3, and another XLT. So we have here two XLT, but they have different formula. Okay, so the formula of LT is, or total inductance, is equal to L1 plus L2 plus L3. So you just only add all these three values of inductors or inductance. Okay, then we have the formula for XL, which is equal to 2 times pi times F times L. And then the formula of XLT. So we have here XLT is equal to XL1 plus XL2 plus XL3. Okay, so solution. So we will substitute the value of L1, L2, and L3. So LT now is equal to 3 millihenry. This one. L2 is 7 millihenry. Yes. And L3 is 9 millihenry. This. So you just add all these three numbers. So your total inductance now is equal to 9 millihenry. Then we are going to solve for the XLT. So we have here the value of XLT. So we will solve for XLT. The value of LT is 19 millihenry. So XLT is equal to 2 times pi times F times LT. Okay, substitute the value of phi, F, and LT. So we have XLT is equal to 2 times 3.14 times 60. 60 is this one. Times 0.019. Now, why I write here 0.019? This is the value of LT. We convert 19 millihenry to Henry. How? You just divide this value by 1000. Why 1000? Because millihenry has 3 zeros. Okay, so milli means 1000. So I divide so that I can change millihenry to Henry. So this value is in Henry. Okay, so 19 divided by 1000 is equal to 0.019. So the value now of XLT is 7.15 ohms. Remember guys that the unit of XL is in ohms. Next, we are going to solve for the XL1. Okay, so XL1 is equal to 2 times pi times F times L1. So this one. Okay, so substitute the value of pi, F, and L1. So XL1 is equal to 2 times 3.14 times 60 times 0.003. So I did not write the 3 millihenry because the answer will be wrong. Same as here. The answer will be wrong if you write the 19 millihenry. So we have to change first millihenry to Henry. So I divide this one by 1000, and which is equal to 0.003 Henry. So the XL1 now is 1.13 ohms. So next we have L2. So the XL2 is equal to 2 times pi times F times L2. Okay, substitute the value of pi, F, and L2. So XL2 is equal to 2 times 3.14 times 60 times 0.007 Henry. So XL2 now will be equal to 2.63 ohms. Then the last one is XL3. So substitute the value of pi, F, and L3. So XL3 is equal to 2 times 3.14 times 60 times 0.009 Henry. So your XL3 is 3.39. Now if you sum up these three XL, this will be equivalent to XLT. So this is the formula of XLT is equal to XL1 plus XL2 plus XL3. So substitute the value of XL1, XL2, and XL3. So your XL1 is 1.13, this one. Your XL2 is 2.63. And then your XL3 is 3.39. So your total inductive reactance is equal to 7.15 ohms. So which is equal here. So remember guys that XLT here is different from XLT here, the formula. But the answer is the same. Okay? So next, how to solve the voltage in each inductors in series circuit. So we are going to apply Ohm's law with this question. Okay, so the same problem, the same value of inductance. So we are going to solve for the IT. Okay, that's the problem here. We're going to solve for the IT, the voltage of L1, the voltage of L2, and the voltage of L3. Then after that, we're going to solve for the total voltage. Okay, so this is the formula. IT is equal to BS, or source voltage, this is the source voltage, divided by the total inductive reactance. Okay, and then we have another formula for VL is equal to IT times XL1. Then we have VL2 is equal to IT times XL2. Then VL3 is equal to IT times XL3. Okay, so solution. Let's solve for IT, or total current, which is equal to VS divided by XLT. Substitute the value of BS and XLT. So your VS is 20, this one, write it here, then divided by XLT. Remember the XLT before, or the previous question that we solved for XLT is 7.15. This is the value of XLT. So 20 divided by 7.15, your total current is equal to 2.79 ampere. This is the unit of the current. Okay. Next, we're going to solve for the voltage of L1. So VL1 is equals to IT times XL1. Substitute the value of IT, which is 2.79 times 1.13. This is the value that this is the question that we answered before, the XL1. Okay, so 1.13. So 2.79 times 1.13 is equal to 3.15 volts. Next, what is the value of VL2? So VL2 is equal to IT times XL2. Substitute IT and XL2. So your IT is 2.79 times 2.63 ohms. So your VL2 is equal to 7.33 volts. Then next is we are going to solve for the voltage of L3. So this is the formula, IT times XL3. So your IT is 2.79 times 3.39, which is XL3. So your VL3 is equal to 9.45. Then we can solve now for the total voltage. So we just only add all the value of voltage, VL1 plus BL2 plus BL3. So substitute the value of all the voltages. So 3.15 plus 7.33 plus 9.45 is equal to 19.93 volts. So this is the total voltage. So your total voltage is equal to source voltage. This will be equal. If it is not equal, then maybe one of these voltages here is wrong, or maybe your total current is wrong. Okay, so remember guys, your total voltage should be equal to Vs. Okay, Vt is equal to Vs, which is equal to 20 volts. So this one, if you round off this will become 20 volts. Okay, so thank you guys, and thank you for watching. See you next online training.